is the observer who is standing on the ground. With respect to the observer, the charged particle is at rest. The velocity is 0, right? And in the second case, there is a stationary observer who is standing on the ground and the charge is moving with constant velocity, right? And in the third case, with respect to the stationary observer, the charged particle is moving with some variable velocity. Variable velocity means you can consider the magnitude remains constant and you can change the direction. Also, you can keep the direction constant, you can change the magnitude of the velocity vector. Also, you can do both the things. You will change both velocity, magnitude and direction. Okay. So anyways, if velocity will be variable, that is the third case. Okay. So in the first case, what the observer will observe? If the observer has some charge to detect the electric field, then the observer will observe only electric field which is constant by magnitude, also by direction. That means the observer will observe only static electric field, and also he will observe a zero magnetic field. This topic is called electrostatic. And the second one, in the second case, you can imagine that a charge is moving in this free space, or you can consider the charge is moving inside a current carrying conductor. Okay. Anyways, if the charge will move with constant velocity, then the main aspect the observer will observe is he will find the electric field to be constant and both magnetic field to be constant. That means he will observe both electric field and magnetic field which are static in nature. This chapter is called electric current. Okay. And case 3 is about the observer will observe a time varying electric field, also a time varying magnetic field. That means, suppose you imagine I am the observer and with respect to me the charged particle is accelerated. Then what actually I am going to observe is a time varying electric field, simultaneously a time varying magnetic field, and both combinedly are considered to be electromagnetic waves. Right? So students, the first topic where the charged particle or the charge will remain at rest with respect to the observer, the topic is called electrostatic. So today we are going to start the first topic, that is electrostatics. In this topic, we will discuss about the charges which are at rest. So let us introduce the topic electrostatics. Deals with the study of charge at rest. So first, I'll give you the definition of charge. Charge It is the fundamental property of any mass or of any object for which it shows electrical attraction or repulsion. Basically, charges are of two types. Charges are of two types. One is positive, another is negative. So, you know about the properties of charges. Some of the properties you know from a school level, that opposite charges attract each other and same charges repel each other, right? So, properties of charge. First property, equal charges repel each other and opposite charges attract each other. And the second property is charge is always associated with some mass. Because already I have discussed, this charge is the property of some mass. So you cannot imagine of a charge which is only charge but there is no mass. When you are discussing about a charge particle means you have to consider some mass. Charge is always associated with some mass, right? Then next important point is conservation of charge. Conservation of charge. So according to conservation of charge, in an isolated system, what do you mean by isolated system? Suppose I'll consider a system which is not at all interacting with the surroundings. You see, imagine this is a isolated system, means this is the system, there is some boundary so that charge cannot escape from the system to surroundings or charge cannot enter from surrounding to system. Let us consider three material particles A, B and C. They have some charge. Suppose QA, here it is minus QB, here it is plus QC. According to conservation of charge, the total charge will remain constant, QA plus of minus QB plus QC is equal to constant. It may happen that suppose the mass A will try to interact with B, there may be some transfer of charge. Suppose I will connect the two charged bodies by some conducting wire or etc. Then some charge may be transferred from A to B or from B to C or from C to